Pythagorean Converse. The Pythagorean Converse is used to answer questions like, do the following side lengths describe a right triangle? The sides of 12, 16, and 20. Well, first of all, we want to ask ourselves the question, is it even a triangle to begin with? Is it a triangle? Remember that to quickly check that, we add up the two smaller sides, in this case it's 12 and 16, and see if it's bigger than the biggest side, which is 20. Here it is, so yes, it is going to make some kind of triangle. Now to the question, is it a right triangle? Well, remember the Pythagorean theorem? C squared equals A squared plus B squared. Let's see if that will work for these three numbers. Of course, C is the hypotenuse, which has to be the biggest side. So 20 is the C. 20 squared and 12 squared plus 16 squared. Well, 20 squared is 400, 12 squared is 144, and 16 squared is 256. And when I add 144 and 256, it does make 400. So these two sides are equal. These three numbers do satisfy the Pythagorean theorem. So yes, not only does it make a triangle, but it makes a right triangle. And this is our Pythagorean converse. Remember that C always represents the longest side. The larger, the greatest of the three numbers will always be our C. We've just shown how we can get a right triangle when C squared equals A squared plus B squared. It will make an acute triangle if C squared is less than A squared plus B squared. Remember, acute angles are less than 90 degrees, and in an obtuse triangle where obtuse angles are greater than 90 degrees, C squared has to be greater than A squared plus B squared. Let's look at some examples. Classify the following triangles as right, acute, or obtuse. Side lengths of 5, square root of 56, and 9. Well, to know which one is the C, which has to be the biggest number, I'd like to know how much is square root of 56. So I type that in my calculator, and that gives me approximately 7.48. The squiggles mean approximately equal to. I don't want to use this in my calculations because it's a rounded answer. I'm just using it to know which side is the biggest, 5, 7.48, or 9. 9 is the largest, the greatest, so 9 will be the C. So I'm doing C squared blank A squared plus B squared because I'm not sure if this is equal. C is 9, so 9 squared blank, and then the other two sides, 5 squared plus square root 56 squared. 9 squared is 81, 5 squared is 25, and square root 56 squared is just 56. Remember, the square is the inverse of the square root, so they cancel each other out. 81 blank, 25 plus 56 also makes 81. Because these are equal, this makes a right triangle. In this problem, because they all have square roots, I can just pick the biggest of what's under the square root. This one is the C. So when I do C squared blank A squared plus B squared, I'm using square root of 6 all by itself. Square root of 4 squared and square root of 5 squared on the other side. Square root of 6 squared is just 6. Remember how the square cancels out the square root, and the same thing happens on this side. 6, how does it relate to 4 plus 5, which is 9? 6 is less than 9, so this makes an acute triangle, not a right triangle. One more. With sides of 7, 2, and 8, picking the largest number, 8 will be the C. C squared blank A squared plus B squared is how I start, and then I substitute 8 squared blank 2 squared plus 7 squared. So 64 blank 4 plus 49. And 4 plus 49 makes 53. 64 is greater than 53, so this is an obtuse triangle. Not a right triangle, an obtuse triangle. Thanks for watching.